This slide is about the introduction to calcined foundations. A calcined foundation is a deep foundation that is used when the top layer of soil is not strong enough to support a structure. It helps transfer the weight of the building or bridge to stronger soil or rock below the ground. This prevents the structure from sinking or settling. Calcined foundations are mostly used for bridge, highway, and marine structures, especially in areas with soft soil or deep water. One example is the Rawang Bypass project, where calcined foundations were used to provide a strong and stable foundation for the bridge.
For theory, working principle of calcined foundation transfer structure load to strong soil or rock, installed by excavating soil inside the calcines, filled with concrete after reaching the required depth. Two load is supported by and bearing resistant and skin bearing resistant.
This case study focuses on the Rawang Bypass, also known as Federal Road 37. It is a 9-kilometer highway located in Selangor, Malaysia. The highway connects Templer Park near Selayang in the south to Serendah in the north. It was built to divert traffic away from the old Kuala Lumpur Ipoh trunk road, helping to reduce traffic congestion in Rawang town and provide a faster and safer route for road users. So the main challenges are soil conditions are not making the same across the site. Soft soil there are three the risk layer of the first one is the surface and layer, the second one is drilling difficult, and the third one is different bedrock. So the surface layer different foundation designs. The soil condition why is the soil condition it becomes weak when wet, so it can cause landslides during heavy rain. Second one is middle layer. Soil conditions so it is stiff and strong the same across the site. It contains soft soil increases the risk of landslide and it makes drilling and excavation difficult. Lastly, different bottom layer require different foundation designs. But it is strong and stable for bridge soil condition bedrock depth on is different at each location are going to build. Next, let's look at the type of foundation used in the Rawang Bypass. The project used hand dug calcium foundation as the main foundation system. Instead of using large drilling machines, workers manually excavated deep circular shaft using tools such as jackhammers and spades. The excavated soil was lifted out using small electric winches. This method was chosen because it was more suitable for difficult hillside terrain and helped minimize disturbance to the surrounding environment. The deep calcium foundation also provided strong and stable support for the bridge tall pillars.
So why do we choose hand-dug chasing? First, because we use a minimal heavy machinery usage. Because we use basic equipment only, we just use a small tripod, winches, and an air compressor, which is no massive crane-mounted drilling rigs. And we can conquer steep slopes that is perfect for inaccessible 45-degree slopes where heavy rigs physically cannot go. And the last one is we save the landscape. We can eliminate the need to cut wide, destructive access roads through the hillside and minimizing environmental damage. So the second one is we do a preserving root systems, which we save the sensitive ecosystems. Hillside trees have interconnect root systems that damaging one area can destabilize the whole slope. So what we do is we do a surgical precision, which excavation is restrict exactly to the diameter of the pile, and then we do a zero collateral damage, that surrounding soil and vegetation remain completely untouched, keeping the natural ecosystem intact. So the last one what we do is we mitigating landslide risk, which zero dangerous vibration. So the heavy machinery creates intense vibrations that can trigger slope failures and landslide on fragile hillsides. So what we do is we do a gentle manual excavation. Hand digging eliminates this vibration entirely, and we do a maintain slope stability. The structural integrity of the natural slope is safely maintained throughout the entire construction process. So the settlement finding that we have found is for deep foundations or kept into bedrock, such as the hand-dug chasms, Used in the wrong bypass, settlement is typically very small and almost negligible. The predicted settlement is compared with the actual measured settlement, which is usually obtained from load testing methods such as the Osterberg-Sells test or static load test. So the interpretation of the performance of the foundation, we have two, which is load transfer mechanism between base resistance and shaft resistance. The results show that both chasms gain a major portion of their total ultimate capacity from base resistance. For example, at pier P6, the base resistance contributes about 31,000 kN, while shaft resistance provides 24,500 kN. This shows that the chasms are effectively socket into competent bedrock, allowing end bearing action to play a key role in supporting heavy vertical loads from the bridge deck. And the second is we do a geotechnical safety margins. According to the JKR requirements for critical highway structures, deep foundations must maintain an acceptable factor of safety, FOS, against failure. The combined ultimate resistance from both piers exceeds the maximum test load, confirming structural reliability. Consequently, pier P5 achieves a factor of safety of 3.2, while pier P6 achieves a slightly higher value of 3.4, showing a stable and conservative foundation design.
Next, we will go through the precaution in Cajun foundation construction. Firstly, we have the worker safety. The worker need to wear PPE such as helmet, boots, glove, vest and also harness. Provide lighting and communication, and also is only allowed for trained workers only. Secondly, we prevent shaft collapse. We need to inspect the Cajun walls regularly and also excavate in stage. Install temporary support if needed. Thirdly, we have the ventilation and air quality. We need to ensure the adequate ventilation, monitor oxygen and harmful gases, and also evacuate if air is unsafe. Fourth, we have groundwater control. We need to monitor groundwater continuously, use pump or dewatering system, and prevent water accumulation. Fifth, equipment safety. Inspect lifting equipment regularly, live excavate materials carefully, and also maintain safe working distance. Number 6, we have environmental stability. We need to protect surrounding vegetation, monitor slopes for movement, and also reduce vibration from machinery. 7, we need to prepare for emergency. We prepare by rescue procedure, provide first aid facilities, and also conduct safety briefing and drills. Lastly, inspection and monitoring. We need to perform geotechnical monitoring, check settlement and shaft alignment, and also repair defects immediately. Thank you.
In conclusion, Hendek-Kaizen was the best foundation for the Rawang bypass because the site has steep slopes and weak soil. The foundation reached strong bedrock and gave good support to the bridge. The settlement was a very small and within the safe limit. The safety factors also met the JKR requirement. Overall, this foundation is safe and also helps protect the environment. For future projects, digital gas detectors and ventilation fans should be used to improve worker safety. Slope monitoring system can help detect landslides early. GPS survey can check the underground boulders before excavations, and fiber optic sensors can be used to monitor the bridge after constructions. That's all from us. Thank you.